For section 4.7, we're going to translate equations in vertex form. So when we do this, we're going to look for and make use of structure. We are dealing solely with the equations today. We're not going to be doing any graphing with this. You're more than welcome to graph to check problems and check answers, but for the work that we're doing, we are only using equations. Equations are all full of structure. We're using the structure of graphs to manipulate equations. Before we do this, though, we need to make sure we know what a translation is and what a shift is. So a translation is a vertical or horizontal movement on a coordinate plane. So you've used this in the past with geometry when you're talking about translation of objects, and you would move the objects around the graph, and sometimes they would have diagonal movements, but what was really happening there was they were moving horizontally, so they were moving left to right, and then they were moving up and down. We're doing that same thing today, but instead of moving objects like that, we're just moving quadratic functions. We're moving the parabolas. We did this in the intro activity earlier this week. So a translation, once again, is a vertical or horizontal movement on a coordinate plane. Next, a shift is just the change that's caused by the translation. So a translation is that movement, and then whatever changes is the shift. So the shift is the change that is caused by a translation. They're basically the same thing. We can use them interchangeably, but for the most part, I'm going to be talking about translations more than I'm going to be saying the word shift. All right, so before we go on, let's make sure we know what vertex form is. I know we've gone over this a lot, but a reminder, vertex form of quadratics is y equals a times the quantity x minus h squared plus k. So we have three different numbers in here. A, h, and k are the three spots where numbers actually go into this equation. Y and x are the variables of it. So there's three different changes that we can make to these numbers in this equation. So what do each of them do? Well, as we discovered in that previous activity, the h causes a left to right movement. This makes sense because h is the x value of the vertex. So if the x value of the vertex is changing, then that means this is moving left to right. So what exactly happens? If the h is positive, or if it has an increase, then that means it's going to move left. Now, typically you would think positive is right, but this is a negative h, so that means that it is going to be the opposite. So a positive change is actually a left movement. That means a negative change, so if we have a negative h or a decrease, then it's going to move right. All right, next let's talk about k. K is just a positive k, so when we talk about k, first of all, we need to think k is the y value of the vertex, which means it's going to be moving up and down. If h is left and right, k is up and down. So when we have a positive change or a positive k, since it is just plus k in the equation, then this is going to be a movement up. If it's negative, then it's going to be a movement down. So we got h and we got k. Those are the two numbers that create our vertex. They create the left and right and the up and down. So then what could a do? we already have all the translations around the graph. A, the only thing that's left is to change the shape or to make it bigger or smaller. And that is what A does. So A changes the width. So if we have an A, and when I talk about A, I'm talking about the absolute value of it. So a reminder, absolute value is the distance from 0 on a number line. In other words, it's the positive of it. So the absolute value of 3 would be 3. The absolute value of negative 3 would also be 3. So when we're talking about the positive of it or the absolute value of it, if it is greater than 1, or if it has an increase, so I'm going to put a plus sign for an increase, then that's going to make it skinnier. If the absolute value is less than 1, or if it has a decrease, then it's going to be wider. This is also called the scale factor, or a dilation, as you learned it last year in geometry. So let's think about why this is. If I have a graph, and let's talk just about the parent function. Here is the parent function y equals x squared. So the a value here is 1. My points, if I have, well, first my vertex is 0, 0. If I plug in 1 for x, I get 1 for y. If I plug in 2 for x, I get 4 for y. All right, so let's look at another equation. Let's look at y equals 2x squared. So let's look at an a that increases or is greater than 1. Well, my vertex is still 0, 0. But if I plug in 1 for x, I get 2 for y. So that point's going to be in there. If I plug in 2 for x, I get 8 for y. So that point's going to be way up there. So this graph now looks like this. So it's skinnier. If I were to look at y equals 1/2 x squared, my vertex is still 0, 0. If I plug in 1 for x, I get 1/2 for y. So that point's going to be down over here. If I plug in 2 for x, I get 1 for y. Sorry, that's wrong. If I plug in 2 for x, I get 2 for y. So that point's going to be about there. So this graph is going to look kind of like that. So it's wider. So when that a value, the absolute value of it, is greater than 1, or if there's an increase, then it gets skinnier. And if it's less than 1 or there's a decrease, it gets wider. So let's go ahead and do some practice. We have 2 different types of problems we're going to do. One of them is figuring out what translation happened, and the other one is, given a translation, what is the new equation? We're going to do each of those just starting with comparing with the parent graph, and then we will throw in other equations that are being translated from. When we go through these, we're starting with the parent graph, and we have a new equation. And it says, we're asked how it is translated. So the first thing we need to think is, what changes in x? Remember, it's the opposite with, or sorry, not with x, with h. So left to right. Remember, it's the opposite. What changes with k, and then what changes with a. So let's go through and do this. All right, so this first one, h, my original h was 0. My new h is -4. So if I look back at my notes, a negative means that it's going right 4. Next, I have k that I need to look at. Well, the k was 0. Now the k is 5. A positive 5 for k means that it's going to go up 5. And then with a, my original a was 1. It's still 1, which means that there's no change. So there's no change in a. I don't need to say anything. This right here is what I'm wanting in your answer. I want to see what direction and how many times it moves. If there's no movement or if there's no scale factor that changes, then you don't need to put it. All right, let's go ahead and do another one. Y equals 1/2 x plus 2 minus 12. So the h goes up 2. So if the h increases, then that means it's going to be a left 2. The k goes down 12 because it has a decrease of 12. And then the a goes from 1 to 1/2. So if it goes from 1 to 1/2, that's a decrease, which means it's going to be wider. So I want to know if it gets skinnier or wider, because just telling me that the scale factor decreases doesn't really tell me much. I want to know what happens to the graph. And that's what I need on that one. One more. Go ahead and pause this video and try this next one. Y equals 2 times the quantity x minus 9 squared plus 3 on your own, and then I will work it out and you can check your understanding. So this last one, the h is minus 9, which means that it's going to go right 9. The k is plus 3, which means it's going to go up 3. And then the a becomes 2, which is an increase, which means it's going to be skinnier. So it goes right 9, up 3, and it becomes skinnier. Now, if you were wanting to check these, what you could do is you could use Desmos or a graphing calculator. You could graph y equals x squared, and then you could graph the equation and see what happens. You can count the change in x, the change in y, and then you can visually see if it gets wider or skinnier. All right, let's go ahead and take this type of problem to another level now. So now we are still describing the translation, but now we're going from one not necessarily parent graph to another graph. So on this first one, we're going from y equals x squared, y equals the quantity x minus 2 squared plus 14 to y equals x plus 3 squared plus 5. So I need to think to myself, what happens with h? Well, h was -2, and it became 3. So to get from -2 to 3, you need to add 5, or you need to increase it by 5. Well, if my h changes by a positive 5, then that means it's going to go left 5. Next, I'm going to do the same thing with my k. My k was 14, then it became 5. To get from 14 to 5, we need to decrease by 9, which means it's going to go down 9. My a was 1. It's still 1, which means that there's no change. So the translation that happened was left 5 and down 9. All right, let's do another one. If you're feeling confident, go ahead and pause this video and try this next one on your own. This next one, we're going from y equals 3 times the quantity x plus 12 squared minus 13 to y equals 5 times the quantity x plus 8 squared minus 3. So first, I need to figure out what happens with my h. So we go from positive 12 to positive 8. To get from 8 to 12, I need to decrease by 4. If my h is decreasing, then that means it's going right. So it's going right 4. Next, with my k, I'm going from negative 13 to negative 3, which means that it is increasing by 10. So that means it's going up 10. And then lastly, my a is going from 3 to 5. That is an increase. If it increases, that means it's getting skinnier. And so my translation is right 4, up 10, and skinnier. All right, that is the first type of problem. The other type of problem is we're given a translation and we need to write an equation in Vertex form for it. So the three things we need to think to ourselves are, how does h change? How does k change? And how does a change? So let's go through this. These first ones, we're just starting with the parent graph, y equals x squared. So with y equals x squared, we're going up 2 units and left 5 units. So let's think about h first. H is left to right, so I'm looking at this change right here. Make sure you're really paying attention to your left and right and up and down. If it's going left 5 units, then that means it's increasing by 5. Next, I have my k. K is talking about up and down. If it's going up 2 units, then it's increasing by 2. And now I need to think about a. Well, nothing happens with a. So now I just need to write my equation. So I have y equals, my a is still 1, times the quantity, x plus 5 squared plus 2. So that plus 5 comes from that left 5, and that plus 2 comes from the plus 2, the up 2. Go ahead and pause this video and try the next one on your own. This next one, we have 3 things going on. First, we are going right 8, because first I'm looking at my left and right for my h. If I'm going right 8, then that means I am going to decrease. Next, I'm looking at up and down. So I have down 12. So for my k, if I'm going down 12, then that means I'm decreasing by 12. And lastly, I am scaled by a factor of 7, which means when I'm talking about scale factor, that would be multiplication. So now I'm multiplying by 7. So my equation is going to be y equals 7 times the quantity, x minus 8 squared minus 12. That minus 8 comes from my h. The minus 12 comes from my k. And that 7 comes from my a. We just have one last kind of problem. We are doing that same thing where we're given a translation, but now instead of going from the parent graph, we're going to be given an equation and we have to translate it. So we're going to go through that same process. Here is my equation. Y equals the quantity x plus 3 squared plus 7. So first I am thinking about my h, which is left and right. So we're going left 2. So my h starts at 3 and it goes left 2. If it's going left, then that means it's increasing. So I'm going to add 2, so my h becomes 5. Next, I'm going to think about my k. Well, my original k is 7, and then it goes down 4, which means I'm going to decrease by 4, so my new k becomes 3. And then lastly, I need to think about my a. Well, my a was 1. There's no change, so it just stays as 1. So my equation is y equals 1, which I don't need to write, times the quantity x plus 5 squared plus 3. So once again, the plus 5 comes from that h, and the plus 3 comes from the k. Let's try another one of those. So this next one, I have the equation y equals 2 times the quantity x minus 1 squared minus 12. So first I'm going to think about my h, which is left and right. So my h starts at -1, and it goes right 4, which means I'm subtracting by 4, so this becomes -5. My k starts at -12. It goes up 22, which means it increases by 22 to become 10. And then my a is 2, and it has no change, so it stays 2. So this equation is y equals 2 times the quantity x minus 5 squared plus 10. Once again, that minus 5 comes from the h, the plus 10 comes from the k, and that 2 comes from the a. That did not change. There's one more problem. Go ahead and pause this video and try this one out on your own, and then of course I will walk you through it once you play the video again. So with this one, I'm going to start with h as usual. H is left and right. I go left 1 unit. So looking at my original equation, y equals 3x squared minus 4, my h is 0. If there's no number being added or subtracted to the x, then that means it's 0, and it goes left 1, which means it increases by 1. So that means that my h becomes 1. Now my k is -4, but nothing happens with my k. There's no left and right, so it just stays -4. And then my a is 3, and it says scale factor of 4. So it's dilated by a scale factor of 4, which means I need to multiply this by 4 to get 12. So my equation now is y equals 12 times the quantity x plus 1 squared minus 4. The plus 1 comes from the h. The minus 4 comes from that k that doesn't change. And that 12 comes from the a that was dilated. All right, that was it for this section. You are good to do the homework and work on some extra practice problems. And of course, as usual, if you have any questions, come talk to me, let me know so we can get it figured out.